Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to create our own custom object detection model for yolov8, and then we are going to detect object, and then we are going to track the object. Also we are going to create a counter for the object which basically moving on a conveyor belt. So before we move to a practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much, and let's get started. So friends, as I mentioned, today we are going to detect object, track the object, and create a counter for the object which basically moving on a conveyor belt. So for that, first just open Tony Python IDE. We are going to install our basic packages. So this is what Tony Python IDE. Go to the tools, manage packages, and search for opencv Python, hit enter, and then first package opencv Python, just click on install button and it will install opencv Python. Then ultralytics package for yolov8. So search for ultralytics, first package, click on install, and then it will install ultralytics. Then cv zone package for putting our text on the frame. So cv zone, first package, click on install, and it will install cv zone. That's it. This is how we need to install our basic packages. So first package is opencv Python, then the ultralytics package for yolov8, and then cv zone package. That's it, done. Now for today's session I have created a new repository. The name of the repository is yolov8 custom obj count conveyor belt. So I will mention the link inside description box. Simply copy paste the link inside the browser, then go to the code, click on download zip, and it will download our zip format repository, as you can see. So now just minimize Tony Python IDE, then open file manager, go to the downloads, and this is what our repository. So right click, winrar, extract with the folder name, and then just go inside the folder. Again we have same folder, and inside that we have our files. So first we need our video file. So just open vid.txt file, copy the link, copy it, and close all these things, and just open browser, open new tab, press Ctrl+V. It will paste our link, the mega cloud link for video file, and then it will open our cloud link. So friends, as you can see, we open our cloud link. So because I have already downloaded, that's why it says the save. So in your case, the button will be, the tab will be download. So simply click on download tab and it will download our video. So let me click on save, and it will save the video file, as you can see. So just close, minimize, go to the file manager, downloads, and this is what our video. So just right click, cut, and move the video file inside our main repository folder. Here, just paste it. That's it, done. Now let's just first watch our video file. So let me mute the volume, just a minute. Okay, that's it. So friends, as I mentioned, this is what the conveyor belt, and we have some packages on conveyor belt which basically moving. So our goal is to create our own custom model for detecting these packages. Then we have our tracker which basically track, which basically assign the ID, unique ID for each package, and with the help of our tracker we are going to simply create a counter, and then we are going to count the packages which basically moving on our conveyor belt. So this is what our video file, this is what our scenario, as you can see. So this is the packages which basically continuously moving on our conveyor belt. Done. So for that, first we need our data set. So data set in the sense the images. So for images we are going to use our video file itself. So img.py, just click on and it will open img.py with the help of our Tony Python IDE. Simple. And here I have mentioned 50 frames is enough for a demo purpose. In real scenario you need more frames. So max frames I have mentioned 50. You can simply change as per your requirement. You can go 2050, Simple. So right now I have just mentioned 5050 is the number, and then here I have mentioned cy.mp4. So this is what our video file name, and here cv2.imwrite, it will capture the frame, or we can say it will capture the image from video, and it will save the images inside the folder. So here we want to mention the path of our folder. So just open repository, and here we are going to create a new folder. So right click, new images, mention the name of folder images, that's it. Then right click to the folder and copy as a path, minimize the manager, and then here simply we want to mention our path. Just remove from images, and here just press Ctrl+V. It will copy paste our new path. Then here it is, as you can see we have double quote. Just remove this double quote, and then at the starting point also we have double quote. Here it is, as you can see, two double quotes, so we need only single, so just remove this one, that's it. So we mentioned the full path. As you can see, this is what our repository. Again inside that we have same folder, and then we have images folder which we just create. And then we want to mention the name for images. So here I have mentioned the pack because this is the packages, so I have mentioned pack, and the extension of image is basically .jpg, and then it will create 50 images. Name of the image is basically now this one, pack.jpg. So it will create 50 images, name with pack.jpg. Simple. So just save the code and run the code. It will start our video frame. As you can see, it started our video frame. Done. So now if you open the repository, if you go inside images, as you can see we have our images inside our folder, the images folder. Simple. So this is how you can collect the data using video file itself, or we can say using any CCTV video for your project. That's it, done. So we have now images. Now simply we want our labelimg software. So on Windows machine, if we want to run labelimg software, so for that we need Python 3.8. So just open this Microsoft Store, and then here we want to search for Python 3.8. So just search for Python 3, and then as you can see Python 3.8. So just click on the Python 3.8 and just click on here install button, and it will install Python 3.8 on our Windows 11 machine. Same for Windows 10 also. So because I have already installed Python 3.8, so simply you need to open Microsoft Store, search for Python 3, and just search for Python 3.8 version. Just click on install button, done. It will install Python 3.8. Now we have our Python 3.8. Now just go to the run, and here configure interpreter, just select it, and this Python, here it is, as you can see, here we want to select our version. So our version for labelimg which we just installed, which is the Python 3.8, here it is, as you can see, Python 3.8 exe. So just select it, click on OK, and then as you can see now inside shell we successfully change our version. So now it's Python 3.8. Done. Now just go to the tools, open system shell, and here we want to install our labelimg software. So just minimize, and now as I mentioned we are on Python 3.8. so here we want to go again tools, manage packages, and just search for labelimg. Just hit enter, labelimg, select it, first package, click on install, and it will install labelimg. Because I have already installed, as you can see, that's why it say uninstall. So this is how you need to install, most easy way you need to install labelimg. Done. Now as I mentioned, just open system shell from tools. Here it is, as you can see, open system shell. Just select it, it will open a system shell, and here we want to run our command, which is labelimg. Just hit enter, and then it will open labelimg software, as you can see. So here we want to select our OpenDIR, go to the downloads, our repository, again same repository, our images folder, select folder, then we have our images. Then change save dir, go to the downloads repository, again same repository, images folder, select folder, done. Now here we want to select YOLO because we are working on our YOLO. So here we want to select YOLO, then create rectangle box, and then just draw the rectangle box on packages like this way. And here we want to simply mention packages, the class name, packages. That's it. Click on OK. Again create rectangle box, go for next package, same class, again create rectangle box, this one package, just same class, click on OK, and then just save it. Again create rectangle box, go for this package, select it, click on OK, click on save. Now if you open the repository images, and inside that, as you can see, we have pack0 image and their text file basically. So inside that text file, here it is, as you can see, we have a coordinates, the rectangle coordinates, simple. So we successfully draw a rectangle with the help of our labelimg software. So now go for next image, again same way, create rectangle box, go here, draw rectangle box, click on OK, create rectangle box, draw rectangle box on the package, click on OK, create rectangle box, draw rectangle box on the package, click on OK, again same way, just draw the rectangle box, click on OK, save it, go for next image, again same way, draw the rectangle box, click on OK, create rectangle box, draw a rectangle box on the package, create rectangle box, draw the rectangle box, click on OK, create rectangle box, draw rectangle box, click on OK, just save it. Again next image, same way, draw rectangle box, click on OK, draw rectangle box on the package, create rectangle box, draw rectangle box on the package, same way. So this is how you need to draw a rectangle box on each image on the object and just mention the class name. So let me draw a rectangle on each image. As soon as I completed this process, I will start a video again. So friends, as you can see, we have done with drawing rectangle on our each object. Done. Now simply close labelimg software, close it, minimize the Python ID, and open the repository where we save our images. So this is what our repository, and inside that we have our images folder. And if I go here and extract as a large icon, so as you can see, we have all the images and their text file. Done. Go back. Now we want to create a new folder, and create the new folder, the name of the folder, mention freedom tech, because inside our Google Colab file I have mentioned the freedom tech folder. So we want to create a freedom tech folder, so freedom tech is the folder name. Then inside that we want to create again two new folders. So first one is basically images, and the next one is basically labels. Simple. So images and labels. Again go inside the images folder. Here also we want to create two new folders. So first one is training, and the next one is basically validation. Just a minute. Validation. That's it. So training and validation, this is the two folder. Again go back and we create a two new folder inside images. So same way, go to the labels folder, go inside the labels folder, and here also we want to create a same folder which is training, and then the next folder validation. That's it. So training and validation inside labels folder, and two folders inside images, training validation, and labels, training and validation. Done. Now what we want to do, we want to just open our images folder, Ctrl+A, copy all the things, just copy it, go back and go freedom tech folder, images folder, then training folder, just paste it all the things over here, then go back, validation folder, just paste it over here, that's it. And then same way in labels folder, training folder, paste all the things, and in validation paste all the things, done. So this is how you need to copy all the data from images to freedom tag, images to validation, then images to training, then go back and labels to validation and labels to training, copy all the data, done. Now we want to create a zip file. So right click to the freedom tag folder, WinRAR, add to archive .zip and click on OK. That's it. It will create a zip file of our freedom tag folder, done. Now we want to upload this freedom tag.zip on our Google Drive. So friends, as you can see, I have opened my Google Drive, right click and file upload, just go inside downloads, our repository, and we have our freedom tag.zip. Just select it, click on open, it will upload our freedom tag.zip on our Google Drive. So meanwhile, we open our Google Colab and just click on upload, browse, and inside that repository, downloads, this is what our repository. I have mentioned the Google Colab file for YOLO8. So just select it, click on open, and it will upload our Colab file on our Google Colab. So friends, as you can see, we have successfully uploaded our file. Go to the runtime, change runtime type, select Python 3, select T4 GPU, click on save, and now just click on connect. It will connect our Google Colab file. So friends, as you can see, we successfully connected. Now we want to simply run our cell one by one. So just click on first cell, done. Then next cell, it will install Ultralytics. So friends, as you can see, we have successfully run our second cell. So now go for next cell, from Ultralytics import YOLO, from IPython display import display and image, just click on, and then it will run successfully. Now we want to cross check if we successfully install Ultralytics YOLO8 on our Google Colab. For that we are going to use online image from RoboFlow. As you can see, doc.jpeg, just select the next cell and it will detect the object from image. Then we can say we successfully install Ultralytics on our Google Colab. So as you can see, the result save inside runs detect predict, means we successfully install Ultralytics. Now if we go here and if we check, our upload is completed. So now simply we can mount our Google Drive here on Google Colab. So this code will basically mount our Google Drive. So just run, click on play button. So we want to connect, just click on connect to Google Drive, select the Gmail ID, then scroll down, click on allow. Now it will mount our Google Drive. So friends, as you can see, we have done. Now inside that, here it is what our freedom tag.zip. Now we want to unzip our file. So just click on next cell, and inside that we have our all images with the text file. As you can see, pack and their text file, done. Now just click on here this folder icon, go to the dataset, then freedom tag. This is what our folder. Here we want to click on these three buttons. So just click on just three dots, and we want to create a new file which is data.yaml. So click on new file and mention the file name, which is data.yaml. This is what our file. Just hit enter, data.yaml. It will create an empty file. So just click on it. It will open our file like this way. Now inside that repository, I have mentioned data.txt file. So downloads repository, again same repository, and this is what our data.txt. So inside the data.txt, I have mentioned some code. So we want to simply copy that code from txt file, open our Google Colab here, and data.yml, just right click and just paste it, done. Now here simply we want to mention our class name, which is package. package, or let's say packages. So this is what our class name, and number of class, of course for this scenario we have only one class. So now simply press Ctrl plus S and close. It will save our data.yaml. Done. We have done. Now if you scroll down, and this is the last cell, it will create our own custom model with the help of 100 epochs. So just click on here and it will start our process. So friends, as you can see, process is started, and then it will start our epochs. And here it is, as you can see, 1 and 100. So it will take some time. Meanwhile, I will pause video. So friends, as you can see, we have successfully completed our process, and result is basically saved inside runs, detect and train. So go to the runs folder, detect, then train folder, and inside that train folder we have weights folder, and inside that we have our best.pt model. So just click here, click on download, and it will download our best.pt, our own custom model. So friends, as you can see, we have successfully downloaded our best.pt model. So go to the file manager, downloads, and then here it is, as you can see, our model best.pt. So just click on cut. We want to move our model inside our repository, so just paste it over here. Done. Now here we want to create our own Cocoa dataset file, a text file where we are going to mention our class. So right click, new, and the file text document coco1 coco1.txt. just open it, and here we want to mention our class, which is package. Simple. File, click on save it. Done. Now here I have mentioned test.py, and inside that test.py I have mentioned the code for object detection. So because we change Python version for labelimg, so we want to again change with latest version. So go to the run config interpreter, and here we want to select this one, first one. Click on OK. Now we back with Python 3.10 version. So here it is, as you can see, this is the basic code. So here I have mentioned our model name, then this is what our video file, and this is our text file coco1.txt, and then we have here a detection. Here it is, as you can see, we have detection, we have rectangle, and then we have tracker. So for tracker we want to send our object detection rectangle coordinates to our tracker. So here it is, as you can see, I have mentioned from tracker import all, because I have explained how we can use a tracker in several videos, so I am not going to explain all these things again. Simple. So if you don't know how to use tracker, I already create the playlist, watch the playlist, then you will get the idea. So I have mentioned here a tracker, then we are simply assigning the ID for each package. Now each package we are tracking with the help of our tracker. We detect the object with the help of our custom model, then we are going to track the object, so we assign the ID. Here it is, as you can see, I have mentioned cvzone.put text rec method, and then it will assign the ID. Now we are ready. Now simply here I will freeze the frame first. So just save the code and run the code. So now friends, as you can see, our model is perfectly working. It's detecting our object. As you can see, there is a rectangle box, and each package now we have unique ID. So for this package we have 0, for this package we have 1, for this package we have 2, for this package we have 3. It means we are successfully detecting our custom object, we are tracking the object, we are assigning the object, we are assigning the ID for each object. So if you press a space button, then of course it will skip our frame, and then here it is, as you can see, we have the ID for each package. Now let's just start our while loop. Save the code, and if I run the code, So here it is, as you can see. For this package we have 0, for this package we have 1, for this package we have 2, for this package we have 3, then back to back the packages are coming. For this package we have 4 ID, for this package we have 5 ID. So our model is perfectly working, we are tracking the object, then we are assigning the object. Now simple, we want to count the object frequency. Done. Now here, for that, let me again freeze our frame. For that we need a center point of our rectangle. So x3, y3, x4, y4. Cx is equal to int x3 plus x4 divided by 2. Cy is equal to int y3 plus y4 divided by 2. This is how we will get a Cx and Cy coordinates. So with the help of CV2 circle, we can simply draw a center point for each object. So if we freeze the frame, if I start again the code, now we will have the center point. Just a minute, what we are going to do here, because I have put the ID on center point, so let's just change the coordinates. So now we are going to mention here x3 and y4. Sorry, not x3 and y4, x3 and y3. Now it will put the ID on rectangle top left corner, and then we can simply see the center point. Okay, so if I save the code, if I run the code, and now as you can see, the ID is over here on rectangle top left corner, and this is what our center point. For this object, this is the center point. For this object, this is the center point. For this object, we have center point. Simple. So we successfully mention here rectangle center point. Now we can simply say here, we want to draw here a line, and then if the center point of our package, if it is touch the line, then we are going to count. Simple. So for that we want to first draw a line. So let's just say, let me start again the code, because we want our first frame. So here let me check. Yes. So here it is, as you can see, I have mentioned here a mouse event function, and with the help of mouse event function, if we move our mouse on the frame, inside shell we have some coordinates, the x, y coordinates. So with the help of these x, y coordinates, we can simply draw a line. So let's just say this is our first package, and this is what their center point. So if I want to detect here, or if I want to detect the package over here from here, so I just want to draw here a line, and then the center point, if touch the line, then we are going to say there is an object and there is a counter. Simple. So let's just say here, so let's just like this way go here. So if for this point we have 262 and 308, 262 and 308 on, and if you go for other side, this is the end point, 308 is same. So here, if you go here, let's just again check like this way, 265 and 315. So let's just mention over here our coordinates, cv2 dot line, and we want to draw a line on the frame, and then we want our first coordinate. So let's just go here, this is what our point, let's just say again from here, 259 311. So 259 311, this is what our x coordinate, and then if you go here, here we want to mention like this way, enough. So 547 314, 547 314, 547 314. Now what we are going to do, because this line is basically like this way, this is the line, so we want to mention this y coordinates same. So if this y coordinates is 311, so this one also we want to mention 311. Done. Now simply we want to mention the color, so let's just say 255, 255, 255, white color, and then the thickness we are going to mention 2. So if I save the code, if I run the code, so now as you can see, this is what our line. So if I skip here a frame, as you can see, the center point of object is now touching our line. Simple. So this is how, using CV2 event mouse move function, you can simply draw a line, because we have now XY coordinates. So as I mentioned, just start line point and just end line point, and then mention the Y coordinates same. For start point, also the end point. Here it is, as you can see, I have mentioned 311. So the end point Y coordinates also 311. Now what we are going to do, instead of mentioning the number integer, we are going to simply create here a variable. Let's just say cy1 is equal to 311. cy1 is equal to 311, and then instead of number, here we want to mention cy1, and then here also cy1. Done. Now we want to mention here offset. So offset is equal to 6 is enough for this kind of scenario. So offset is equal to 6. Done. Now as I mentioned, what is our condition? When the object center point touch our line. So for that, the object center point is basically Cx and Cy, and the line which we are going to use here is basically the Cy1. So let's just say here, if the Cy1, if it is less than Cy, this Cy, center point Cy, plus offset which we mentioned 6 over here, this one. So if Cy1, this Cy1, if the Cy1, if it is less than Cy plus offset, and again Cy1 if it is greater than Cy minus offset, means what is the condition? If the Cy1 is less than Cy plus offset and Cy1 is greater than Cy minus offset, means when the object center point touch the line, then only we are going to draw a circle, then only we are going to draw a rectangle, then only we are going to assign the ID for each object. Now save the code and run the code. And now as you can see, there is no rectangle, there is no ID, there is no center point on our packages, because the packages center point is not touching our line. But when it touch the line, then we have rectangle, then we have center point, then we have unique ID for each object. So let's just skip the frame. Watch, here it is. For this package, here it is, as you can see, this package center point, if it is touch the line, then we have pink color rectangle, ID 0 and the center point. So now let me start the while loop for here. 1, save the code, run the code. Now we started our while loop, and watch. For this package, right now there is nothing, but when the package center point touch the line, there is a rectangle, there is a ID, there is a center point. Watch for this package. When the package touch the line, there is a rectangle, there is a center point, there is a ID for this package also, as you can see. So the process is basically continue going. Now we can simply create the counter. So now this is what our condition, then we have circle, rectangle and put text method. Now here we can simply create a counter. So let's just say pack dot append. So when our package touch the line, we have their unique ID. So we are going to simply saving their ID inside the list. So pack dot append, and we want to save their ID, and here we want to create pack is equal to empty list, and then pack dot append and ID. Now simply if you go here and if we print a pack, save the code, run the code. So here it is, as you can see, when the package touch our line, we have their ID inside the list. But the package when touch the line, meanwhile it will take some time for crossing the particular area which we mention as a line. So it will basically counting same ID again and again, as you can see 0 0 1 1 1 2 2. So here we want to simply create a condition, if pack dot count, if pack is basically our list name, here we mention pack, and the count is basically function. If pack dot count, and what we are counting, we are counting their ID and is equal to 0, means please don't count same ID again and again. Now it will count ID only once when it touch the line. So now inside the shell, here it is, as you can see 0, then we have next package, so we have 1, as you can see 0 1, means we count only 2 packages. So now this is the list. So if we go here and if we mention the length of our pack, our list is basically our counter, our number. So I have started the frame again. Now inside shell, as you can see, we count 1 package. Then this one is basically 2, 1, when touch the line, here it is, as you can see, we now count 2 packages. So we have successfully counted. Now here let's just say CP is equal to this, the length of pack, and then we are going to use our CV zone put text method. So just copy it and just paste it over here, and then we are going to mention this, instead of ID we are going to mention our CP, which is our counter, and then simply mention count like this way, and then instead of x3 y3 we want to mention the frame coordinates. So let's just say 16 50, or let's just say 50 60 50 60 and 1, or let's just go 2 1. This is the rectangle size and this is the text size. If I run the code, and now as you can see on the front we have counter. So we count 1 package. So this is what our second package, when the package touch the line, we have counter 2. When package touch the line, so we already count 2 packages. When this package touch the line, we have 3, as you can see. So we count 3 package, which is basically moving. Then this one is 4th, and this one is 5th one, as you can see. So we successfully create our own custom model. We detect our object, we track object, we create a counter for conveyor belt, for object which basically moving on conveyor belt. I hope you will learn something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.